We're going to look at mixture problems. I would like to apologize in advance that I am a little under the weather, so hopefully I will not have a coughing fit during this lesson. Mixture problems. Kentucky State Standard. Create equations that describe numbers or relationships. 1. Create equations in one variable and use them to solve problems. Solve equations and inequalities in one variable. Number 3. Solve linear equations in one variable. Previous knowledge. Solving linear equations with variables on both sides and understanding of percentages. Mixture problems. A mixture problem occurs in many different situations. One example is a store owner may wish to mix two products, two goods to sell a new blend at a given price. A chemist may wish to obtain a solution of desired strength by combining other solutions. In either case, I recommend setting up a table. Here's an example of a generic table. You have the two items that you're going to combine, and then you have the mixture. And each one of them will have an amount, gallons, pounds, liters, however much that you're going to be combining. And then they'll have a weight, which could be a percentage, a price, a concentration, whatever the situation may be. Note that the mixture should be, the amount of it should be equivalent to item 1 plus item 2 should give you the amount of mixture, because you would be adding those two mixtures to get, or those two items together to obtain the mixture. So let's look at example 1, so this will make a little more sense. So example 1 states, how many pounds of coffee worth $1 per pound must be mixed with 15 pounds of coffee worth $1.60 per pound to obtain a mixture worth $1.20 per pound. So what we have in this situation is we've got two coffees that we're going to mix to make a new blend. Now we know that one coffee, which we'll call coffee A, costs $1 per pound. Coffee B is worth $1.60 per pound. We want to mix these so that our mixture is worth $1.20 per pound. It states that we have 15 pounds of coffee B. We want to know how much of coffee A will we add to coffee B. As I stated up in the generic table, these two values must be added to give you the amount of your mixture. Once you have your table set up, it's much easier to move from it to your equation, because what we'll do is we'll take each amount and multiply by its weight. So I have $1 times X. We're going to add that to $1.60 times 15. Together, those should give us our mixture of $1.20 times X plus 15. Once you get here, it's just a matter of solving a linear equation. So 1 times X is X. 1.6 times 15 is 24 equals, now we have to distribute this 1.2, so I'll get 1.2x, and then 1.2 times 15 is 24. It's 18. Now we have the equation. We need to solve, so I'm going to get my x's on the same side. So I'll subtract x from both sides, which leaves me 24 equals 0.2x plus 18. Then I'll subtract 18 from both sides, which leaves me 6 equals 0.2x. 0.2 is multiplied, so we will divide it, which leaves me x equals 30. Now the last step is probably the most important step. You must go back and answer the question. Just because you found x, that doesn't mean you've answered the question. Our question was how many pounds of coffee worth $1 must be mixed with the 15 pounds of coffee worth $1.60. Our x represents the amount of coffee A, which was $1. So we would say 30 pounds of the coffee worth $1 should be mixed with the other coffee in order to obtain the desired solution. Now, it's also important that you ask yourself, does this make sense? Does this answer make sense? If we had gotten a negative answer, would it have made sense that we mix a negative amount of coffee? The answer is no, that would not make sense. Likewise, would it make sense if we had an answer like 3,000? Would it make sense to mix 3,000 pounds of coffee? These sorts of questions will help you catch little errors and see if what you're doing makes sense. So let's look at another example. Example 2 says, how much water must be added to 14 ounces of a 20% alcohol solution to obtain a 7% alcohol solution? So you have the scenario where you need a 7% alcohol solution, but all you have on hand is a 20%. So once again, we'll set up our table. So we have our alcohol solution, which we know is 20%, and we have water that we're going to add to it to obtain our mixture, and our mixture should be 7%. Now my question to you is, how much alcohol is in water? Well, the answer is 0. There is no alcohol in water. So it's 0% alcohol, but everything must have a weight. Now, if it was pure alcohol, you would say 100%. So we have a 0% solution that we're going to add water to in order to get a 7% solution. Now we need to figure out how much of each we have. So it says how much water, so we don't know how much water we have, must be added to 14 ounces of the 20% solution to obtain a 7% solution. Well, our mixture will be the 14 ounces plus however much water we add. Now with percentages, we can't put percentages into our equation. We must change them to decimals. So remember, percent means to divide by 100. If you divide by 100, you move your decimal 2 places. That becomes 0.2. That becomes 0.07. So now we'll write our equation. So I have 0.20 times 14 plus 0 times x equals, that's the two things we're adding together. So together they're going to equal 0.07 times 14 plus x. Now you just need to solve that equation. So you would start by 0.2 times 14, which is 2.8. And 0 times anything is 0. And then again, we have to distribute. So we have 0.07 times 14, which is 0.98, plus, we're going to multiply that by x, and we have 0.07x. Now this time we only have the one x, so we'll subtract 0.98 from both sides. Now you could technically get rid of your decimals by multiplying everything by 100, but we'll just work this out with our decimals. Maybe. I get 1.82 is equal to 0.07x, and we need to divide. And I've got 26. So x equals 26. But once again, you must go back and make sure that you answer the question. The question was, how much water must be added? In our chart, x does represent the amount of water. So what we would say is you would need to add 26 ounces of water to the alcohol solution of 20% in order to obtain a 7% solution. And again, take time to ask yourself, does that make sense? Example 3. Example 3, we have a chemist that is needs 5 liters of a 50% salt solution, a saline solution. all she has available is a 20% salt solution and a 70% salt solution. So how many liters of each solution should she mix to obtain her desired amount? So we have two different salt solutions. She wants to obtain, she needs 5 liters of a 50% salt solution. So we're going to put that over in our mixture. That's what our final solution should have. But she has a 20% solution. We'll call that solution A. And she has a 70% solution. And she wants to know how many of each she needs. Now, we could call solution A and B, but then that gives us two variables. We don't want to solve a two variable equation. We only want to solve a two variable equation if possible. So if I let solution A be X, what can solution B be so that X plus that amount is going to equal 5? Well, simply think of this as an equation. This plus this equals that. So you could subtract that and say 5 minus X. So if I take this and add it to that, would I not get 5? And the answer is yes, because X and negative X would go to 0. So once you have your table set up, remember that percentage, that becomes 0.20, that becomes 0.70, and that becomes 0.50. And you don't need the 0 unless you're dealing with significant figures. So we're going to multiply this out, and I'm going to have 0.2 times X plus 0.7 times 5 minus X. Together that will equal 0.5 times 5. Once your equation is set up, you just need to solve. So we'll leave that alone. I must distribute to my 7, 0.7, 7 tenths. And then I'll multiply my 5 tenths with my 5. On this side of the equal sign, I'm on the same side of the equal sign, so I'll just combine, no moving, no changing signs, no inverse operations. I'll just combine 0.2 and negative 0.7 and get negative 0.5 X. Then I will subtract my 3.5 from both sides and get negative 1. Divide by negative 0.5 or negative 5 tenths. And I get 2. And again, what does that 2 represent? You got to go back and answer the question. This time it wants to know how many of each solution. Well, X is underneath solution A, which is 20%. So we need 2 liters of the 20% saline solution or salt solution, which would leave, if we have 2 liters of that, we have a total of 5. So 5 minus 2 would leave me 3 liters of the 70% saline solution. So this time our solution, or our answer, was a little more in depth. We had to explain both solutions and how much we would add of each of the 20% and the 70%. Previously, we only had a question of 1. What would we add of 1? So again, make sure you answer the question and ask yourself, does it make sense? Another example is a garden. We're going to build a garden, our dream garden. We need 13 cubic yards, okay? So that's a volume, cubic yards of soil containing 40% sand. Now we have 2 types of sand or soil on hand that we can combine to get this. One is 26% sand, and the other is 52% sand. So how many of each should we use? So we know that we want our final to be 46% sand. And we need 13 cubic yards of that. Now we have a 26% sand and a 52% sand. And we need to know how much of each we should combine to get our 13 cubic yards of 40%, 46%. Now again, one of these will represent X. The other will be 13 minus X. My question is, does it matter which one? The answer is no, it doesn't matter. You will fix it when you answer the question again, which is why that's probably the most important part. So just to mix it up, I'm going to let this be X this time as opposed to the first one. And this will be 13 minus X. Because remember, this soil A plus soil B must give me the mixture amount. Once I have my chart filled out, I'll change my percent to a decimal and I'll multiply. I'll add that with my percent as a decimal and I'll multiply. My percent as a decimal and I'll multiply. Again, we're just ready to solve our equation. So I have 0.26 times 13, or 26 hundredths, times 13 is 3.38, or 3 38 hundredths, minus 26 hundredths x plus 0.52x equals 5 and 98 hundredths. Now, once again, our x's are on the same side of the equal sign, so we can combine those. No reason to use inverse operations. So I'll get a positive 26 hundredths x. I'm going to subtract 3 and 38 hundredths from both sides. And I get 2.6, or 2 and 6 tenths. Then I need to divide in order to get x completely by itself. And I got 10. And it's like 10 what? What does that 10 represent? So we've got to go back to our chart and back to our question. Well, that 10 represents 10 cubic yards of this soil that is 52% sand. We need 10 cubic yards of the soil that is 52% sand, which leaves how many cubic yards do we need of the other soil? Of the soil that is 26% sand. Well, to get that, we'll simply take 13 minus our 10. Pen's not showing up. Which gives us 3. So we'll only need 3 cubic yards of the soil of 26% sand. And it's, again, does that make sense? And it should make sense if you think about it. Our mixture is 46%. This is 52%. Those are very close. So you should need more of soil B than you need of soil A to get close to that 46%. Okay. Let's look at one more example. This time we're going to make vegetable oil. We have 6 pounds of vegetable oil was made by combining 2 pounds of soybean oil, which costs $4 per pound, and 4 pounds of canola oil, which costs $1 per pound. What is the cost per pound of the mixture? So once again, take what you know and fill in your chart. I have 6 pounds of vegetable oil. So we know that our final amount of vegetable oil is 6 pounds. And it was made by combining 2 pounds of soybean, and 4 pounds of canola oil. And again, remember, this plus this must equal this. Is 2 plus 4 equal to 6? And it is. And it says that the soybean oil was $4 per pound. The canola oil is $1 per pound. So it's asking how much the vegetable oil would be per pound. So notice that our variable has moved to a different spot now. But writing your equation is the same. It's $4 times the 2 pounds you have plus the $1 times the 4 pounds you have. And that's equal to X times the 6 pounds of solution. So 4 times 2 is 6. 1 times 4 is 4. 6X. And then you add these two together and you get 6X. Then you divide by 6. Normally I would make you leave your answer as a fraction, but remember X is representing money in this case. We usually don't say money as a fraction. So we get 1.66 repeating. Again, we're talking money here. So how would we answer that question? You've got to make sure you answer the question. So following the rounding rules, you would say $1.67 per pound for the vegetable oil. Okay. Make sure you ask yourself, does that make sense? And does it make sense that the vegetable oil would be approximately $2, just shy of $2, if you're adding a $4 oil with a $1 oil? And the answer is yes, because you're predominantly adding the $1 oil, so that would bring the price down. Now, would it have made sense if we had like $6 sitting there? Which, if you're adding a 4 pound and a 1 pound, it should not make sense that your mixture would be more than your largest amount. So those are the type of questions to get used to asking yourself. Does this make sense?